For question 9b, part 1, they want me to show that R is the minimum point path on this chain. So R, they said, is 0, 2. So I need to show that that is the minimum point. So I'm looking at turning point. What do I know about a turning point? Slope is 0. So if I have y is equal to e to the x over 2 plus e to the minus x over 2 as my function, then dy dx is equal to a half e to the x over 2 minus a half e to the minus x over 2. Now, this I did fast, but you could just use your chain rule. So here it's e to the u, where u is x over 2. And so your function is e to the u, where u is x over 2, or a half times x. Okay, differentiate this, you end up at e to the u, multiply by the differentiation of this, which is a half, and that's where you get half e to the half x, or that's the same as half e to the x over 2. And you do the same here, and you end up with this. So that's dy dx. What do I know about turning point? Dy dx is equal to 0. So I'm just going to let this equal to 0 so that I can find my x coordinate. And multiply across by 2, I end up at e to the x over 2 minus e to the minus x over 2 is equal to 0. That is the same as e to the x over 2 minus 1 all over e to the x over 2 is equal to 0. You could multiply across by e to the x over 2. So if I multiply this by e to the x over 2, I end up at e to the x over 2 to be squared. Minus, if I multiply this by e to the x over 2, I end up at 1 is equal to 0. Power to a power means multiply, and I end up with e to the x there. Minus 1 is equal to 0. So I end up at e to the x is equal to 1, and I take this out of log format. Sorry, I take this out and I go, using logs, I can go e to the power of what? Sorry, you could use logs, or you could just go e to the power of what gives me 1, and that's 0. So I am right so far that x is 0, and I go back and I get y. Y is equal to e to the 0 over 2, it's e to the minus 0 over 2. That's e to the 0 plus e to the 0. Anything to the power of 0 is 1, plus anything to the power of 0 is 1. Y is equal to 2. So I know that I'm right with the point 0, 2 is the minimum point on my graph. The next thing in part 2, they want me to show by calculation that the slope of the tangent to the curve is always increasing from R to Q. Now, when you're going from R to Q, you have the points, so R, they have told me is 0, 2, and Q is 4L, which means that my x coordinate is between 0 and 4. That when I get my function here, I'm looking just particularly for anywhere between 0 and 4, because some of my function is actually decreasing if I look at it, but from here to here on my diagram, they want me to prove that it's increasing. So how do I prove something is increasing? I'm going to prove that the slope is greater than 0. Again, I have my slope formula, and if I look at my slope, that the slope of the tangent to the curve is always increasing. Well, if dy dx is the slope of the curve, then if I differentiate that a second time, then that's the rate of change of the slope of the tangent to the curve. So a little bit tricky here, that it's, you know, a little, I have to kind of try and fully understand what they're asking me to do. They want me to show that the slope of the tangent to the curve is always increasing. So in this case, it's the slope of the tangent to the curve that's always increasing. So I'm looking for the second differentiation here. Now, there could be another way to do this, but we'll have a look at this way for the minute. So if I get my second differentiation, so if that's my original and that's my differentiation of it, then I need to differentiate this. Again, I'm going to use my chain rule. And when I use my chain rule, I'll end up with a quarter e to the x over 2 plus a quarter e to the minus x over 2. And I'm going to take the quarter out in common. And if I look at this, for x between 0 and 4, I'm always going to get a plus answer here. Times a quarter is always going to be a plus answer. That is definitely greater than 0. So because the second differentiation here is greater than 0 for x between 0 and 4, I know that the slope of the tangent is always increasing from R to Q.